A very good afternoon to all the students to be present there. Hope you are all fine at your places. Now, today we will start our class for control system. Now, in today's lecture, I think in the previous lecture we were discussed about the introductory part of your control system. What do you mean by this control system? We have two types of system, that is called as an open loop system as well as the control loop, closed loop control system. So in that case, we will see that what is the difference between the open loop control system and the closed loop control system. And after that, we will discuss about the term that is called as the transfer function. Okay. So from Monday onwards, what we have to do, we are starting your numerical based problems, and the topic that we will share or we will start with you is your you can say that unit number 3, that is called as block diagram reduction technique or block diagram representation technique. And in this chapter you will see that how you can solve the numerical problem. The reason being, if your paper from the examination point of view, if your papers will be goes offline, then then most probably these type of numericals will be asked in your question papers. But if your papers will be go on online, again these type of questions will be asked to you. So you have to be get your numerical part to be ready, that how you can solve the given problems or how you can solve the given numericals in case of a control system. Okay, so from Monday onwards we will start your numerical based problems. So we will practice more and more numericals on these topics. Okay, now today what I have to do, basically I will go through some YouTube channels, and from that YouTube channels I will get some videos for you people, so that you people get understand that whatever I will taught you in my previous lecture, you can just get an idea that what do you mean by this control system, what do you mean by this open loop control system, and what do you mean by this closed control system. And also the chapter that we will start in our future from Monday onward, that is called as a block diagram. So you just got an idea that how you can say that these type of numericals we will solve. Okay, now I will share my screen to all the students to be present there. It's humble request to all the students to be present there. You please watch these videos carefully, because after watching this video you just got an idea that how what I had taught you in my previous lecture. So you just got an idea that exactly what will happen. Okay, so first of all, I will share with you one lecture, that is an introduction to the control system. Okay, fine.
Grammarly does more than catch errors. With Grammarly, you can find really good. Hello everyone, and welcome to this wonderful course on control systems. I'm your instructor here to take you throughout this journey on control systems. This is the first lecture, so let's start with the session outlines. In this presentation, firstly, we'll discuss the introduction to the subject, to what we study. Then after that, we'll discuss the reasons that why we need to study this control systems, or the advantages of using control systems. And at the end, we'll quickly see the syllabus and the target audience. So let's start with the introduction to the subject. Control systems.
It's a request to all the students to please watch this video carefully. You can get an idea about the control system.
So to study the control systems in a predefined manner, let's start with the statement or the definition of control systems. A control system consists of subsystems or processes assembled for the purpose of controlling the output of the processes. It simply says that a control system consists of subsystems or the processes assembled for the purpose of controlling the output. Note this statement, controlling the output. So we can say that any control system will take an input, it will process the input in a predefined manner, and it will generate a desired output. For example, an air conditioner maintaining the temperature
this
of
example
the room.
I have already quoted you.
Case,
Air conditioner maintaining the temperature at a particular room.
And the maintained temperature of the room is the desired output. Example number 2, a car moving from rest to a speed of 100 km/h. Now in this case, the car or the elements present in the car are the control systems, and the speed of 100 km/h is the desired output. Example 3, a lift moving upwards. Now in this case, the lift is the control system and the desired floor of the building is the desired output. So all these are the control systems controlling their respective outputs. So now we are done with the statement of control systems and we have understood some of the examples. Now let's understand this in a better manner with the help of a block diagram. If this is the block diagram of any control system, then on this side we have the input or the stimulus to the system, and this is the desired response that we want from the system. On this side, we have the output or the response of the system to this particular input, and this is the actual response that we get from the system after the process is done. Every time, the desired response is not same as the actual response, and the difference in the actual response and the desired response is the error of control system. We will discuss the input, the output, the desired response, and the actual response of any control system in the upcoming lectures of this course. As of now, we just know that any control system will take an input, it will process the input in a predefined manner, and it will generate an output. So now we are done with the block diagram of any control system. Now let's move on to the question that why we should study control systems or the advantages of using control systems. We build the control systems for four primary reasons: power amplification, remote control, convenience of input form, and the compensation for disturbances. We will understand all these reasons with the help of a practical example. Suppose we have a radar antenna and we wish to rotate this antenna through a certain angle. Then in that case, we will use a rotating knob and we will rotate this knob through a certain angle, and the radar antenna will rotate through the same angle. But note that the power required to rotate this knob is quite small as compared to the power required to rotate this heavy antenna. So in that case, we need to amplify the power and we use motors for that purpose. And motors are control systems. So now we understand that we need control systems for power amplification. In this way, we are done with the first reason. Let's move on to the second reason, which is remote control. Again, whenever we need to rotate this radar antenna, we use rotating knob. And this rotating knob is like a remote control element for this radar antenna. We can have one more example, a remote controlled robotic arm that can be used to pick up materials from a radioactive environment. So the control systems are also useful in remote areas. In this way, we are done with the second reason. Now let's move on to the third reason, which is convenience of input form. Again, whenever we need to rotate this antenna, we are rotating this knob or we are repositioning this knob. In this way, we are changing the form of the input. We can have one more example in this case. Suppose we are inside air-conditioned room and we need to decrease the temperature inside the room. Then in that case, we will use the remote control to decrease the temperature of the air conditioner. So in this way, the control systems are also useful to provide convenience by changing the form of the input. In this way, we are done with the third reason. Now let's move on to the fourth reason, which is compensation for disturbances. This is one of the most important reasons to build a control system. And we will consider the same example to understand this particular reason. Already we are having the radar antenna which is pointed in a commanded direction. Now consider a case in which wind forces this antenna from its commanded position or noise enters internally. Then in that case, this radar antenna itself has to detect the amount of error occurred and it has to correct that error by itself. Note that we do not change the input according to the disturbance. So the control system itself has to deal with the error that has occurred and it has to correct the error by itself. And in this way, the control system compensates for disturbances. So now we are done with the introductory portion of control systems and we have discussed the reasons to study control systems. Now we will discuss the syllabus and the target audience. Talking about the syllabus, we'll firstly discuss the basics of control systems, in which the very first lecture will be the system response characteristics, and in that lecture we will discuss that how the output of any control system vary with respect to the input. And after that, we will have an introduction to the open loop and closed loop systems and their comparison. Then after that, we will have a review of signals and systems, in which we will mainly focus on the Laplace transform and their properties. And after that, we will discuss the transfer function of any LTI system. Then after that, we'll have a concept of feedback and the types of feedback. After the completion of feedback, we will discuss the sensitivity of control system. And at last, we will discuss the concept of dominant pole. In this way, we will discuss the basics of control systems. After the basics of control system, the next chapter will be the block diagram reduction and the
That
signal
chapter I
flow
have
graph.
started from Monday
In this
onwards.
chapter,
Block diagram
we will
reduction
discuss the
technique and
basic rules
signal
for
flow
the
graph.
block diagram reduction and the Mason's gain formula for calculating the overall gain in the signal flow graph. After the completion of this chapter, we will move on to the next chapter, which is the time response analysis. In this chapter, we will discuss the transient response for first order system, the transient response for second order system, the concept of damping, the transient response parameters, and we will also have discussion on the steady state and the steady state errors. In this way, we will complete this chapter and then we will move on to the fourth chapter, which is the stability. In this chapter, we will mainly focus on the Routh-Hurwitz criteria for the absolute stability of any control system. After the completion of this chapter, we will move on to the fifth chapter, which is the root locus diagram. Then after that, we will move on to the frequency response analysis chapter. And from this chapter, we will completely switch to the frequency domain. In this chapter, firstly, we'll discuss the frequency response parameters of a control system. And we will have discussion on various frequency response analysis techniques like polar plot, Nyquist plot, and Bode plot. Then after that, we will move on to the next chapter, which is compensators and controllers. And after completing this chapter, we will move on to the last chapter of control system, which is the state space analysis. And this chapter is the complete different approach towards a control system. We will discuss various state space parameters and the state variable representation of a
See, this is the complete syllabus for your courses also. Like here, you can represent that the basics of the control system, block diagram prediction technique, signal flow analysis, time response analysis, stability, root locus diagram, frequency response, compensator and controllers, and speed spread analysis. So also when we have to teach this whole subject, we have also discussed all these types of, you can say that our systems. Okay, fine. So this is the introductory part that here you can deal that what do you mean by this control system. You can just got an idea about the definition of the control system and the sorry, we can say that the why we require this control system, what are the various areas of application of the control system. Okay, now I can also remember that in my second lecture we were discussed about with you people about I can say that about the different types of control system occur, that is called as open loop control system and closed loop control system. So now I will share with you one more video, that video related to the open loop control system and the closed loop control system. Now you can watch this open loop control system and closed loop control system. And after watching this open loop and closed loop control system, we are switching towards our first topic, or you can say that the unit number 3 of that control system, that is called as the block diagram reduction technique. Okay, so now I will get video on your you can say that just in a minute I will show you the video on you can say that open loop as well as the control loop flow system. You can watch this video now.
सुनो, इधर ध्यान दो, इम्पोर्टेंट बात करके तुम्हारे साथ एनआरए सीईटी आने वाला है इंडिया में पहली बार। बहुत everyone and welcome back to the next lecture of control systems. In this lecture, we will discuss the open loop systems. In the previous lecture, we discussed the system response characteristics, and in that lecture, at the end, we had discussion on the system configurations. We have two types of system configurations. One is the open loop configuration and the other is the closed loop configuration. And on the basis of system configuration, we have two types of systems. One is the open loop system and the other is the closed loop system. So now in this lecture, we will discuss the open loop systems. So let's get started. We have discussed the block diagram of control system, and we all know that any control system will take an input, it will process the input, and it will generate the output. But internally, the control system is divided into two different sections. One is the controller section that controls the amount of input that is required to process the input, and the other is the process section that actually processes the input in order to generate the output. On the left side, we have the input to the system, and from now onwards, we will call this as the reference input, and on this side, we have the output. So now we can say that any control system will take an input, and inside the control system, the controller will control control the amount of input that is required for the process, and the controlled input will move on to the process section, and it will be processed in the process section in order to generate the output. In this way, we are done with the block diagram of open loop system. Now let's move on to some of the important points of open loop system. Open loop control system is a system in which the control action is totally independent of the output of the system. This point simply says that the input to the system is totally independent of the output. It means that we don't have a feedback signal that tells us how to vary the input, when to increase or decrease the input signal in order to get the desired output. In that case, the accuracy of the system depends on the experience of the user. To understand this, one classical example is immersion water heater. That immersion rod that we put inside the water to heat it. Yes, that one. It goes on heating the water, but it doesn't have a feedback mechanism to tell you how hot the water is and when to stop heating the water. That's why it is a perfect example of an open loop system. One more classic example is of a toaster. The toaster goes on increasing the temperature of the bread, but it doesn't know when to stop heating. And that's why sometimes we get to know that the toast has burnt. So now we are done with the introduction of open loop system. Now let's move on to the advantages of using open loop system. The first advantage of any open loop system is it is simple in construction and design because it does not have a complex mechanism. Also, it is economic because it does not have many elements present in it and the circuitry is simple. Also, it is convenient to use when the output is difficult to measure. So we have some advantages of using open loop systems, but on the other hand, we also have some disadvantages. And the major disadvantage of using any open loop system is it is poorly equipped to handle disturbance. And as it can't handle disturbance, it is not reliable. So in order to remove the disadvantages of open loop system, we will add one feedback factor from the output side to the input side. And in this way, we will move on to the closed loop systems. We will discuss the closed loop systems in the next lecture. As of now, we are done with this lecture. Thank you for watching this lecture. I'll end this lecture here. See you in the next one.
So this is I closed loop control system that I have already discussed with you. Closed loop control system. Now it's the time you can please watch this video for the closed loop control system. Okay, so this is the closed loop control system.
Hello everyone and welcome back to the next lecture of control systems. In this lecture, we will discuss the closed loop systems. In the previous lecture, we discussed about the open loop systems and we also had discussion on some of the disadvantages of using the open loop systems. And we all know that the open loop systems are not reliable because they are not able to handle the disturbance. So now in this lecture, we will try to overcome that disadvantage and let's see how we can do it. So let's get started. This is the block diagram of an open loop system that we have already discussed in the previous lecture, and we know that the open loop systems are internally divided into two different sections. One is the controller section, which controls the amount of input that is required for the desired output, and the process section processes the input in order to generate the output. But the major disadvantage in case of the open loop systems is that it does not know when to stop, or it is not able to handle the disturbance. We took one example of an immersion water heater in the previous lecture, and we know that if we put the heating rod inside the water and we turn the switch on, then the immersion water heater starts heating the water, but it does not know when to stop heating. Or we can say that open loop system does not know your desired output, and that's why it goes on heating the water until you turn the switch off. So in order to maintain the desired output, we need to measure the output continuously, and we do it by using a feedback signal. In the closed loop systems, we can say the output is measured continuously and is fed back to the input, where the error with respect to the desired output is detected. Call this unit as the error detection unit. And then after that, the signal goes to the controller. The controller then controls the amount of input according to the desired response, and then the controlled input goes to the process section, and hence we get the desired output. And this time the desired output is maintained. And in this way, the presence of feedback compensates for the disturbance and it improves the accuracy of the system. An air conditioner is a very good example of a closed loop system. It continuously monitors the temperature inside the room and accordingly it turns off and starts over the compressor which is present outside the room, and in this way it maintains the desired temperature. We can have one more example of a geyser. A geyser is a water heater, but here we can set the desired temperature. It continuously monitors the temperature of the water present inside and it turns off and starts over again in order to maintain the desired temperature. Whenever the desired temperature is achieved, the geyser will turn off. And after some time, when the temperature decreases, it starts over again in order to maintain the temperature. So now we are done with the introductory portion of closed loop systems, and now we will have a comparison of open loop systems and the closed loop systems. Moving on to the comparison between the open loop systems and the closed loop systems, we can say that the
That
accuracy
difference I
of
will
open
already
loop
tell you
systems
in
is
detail
low
in my
because they
previous
can't
lecture to
handle
you.
disturbance. Whereas the accuracy of closed loop systems is high because they are able to handle disturbance. The open loop systems are not that reliable because they are not accurate. On the other hand, the closed loop systems are more reliable because they are more accurate. The open loop systems are easy to design because there is no feedback factor involved and the circuitry is simple. Whereas the closed loop systems are complex in design because an additional feedback factor is involved and the circuitry is complex. Due to all the three reasons, the open loop systems are less expensive as compared to the closed loop systems. But the closed loop systems are expensive. And now, what is the distinguishing factor between the two? Yes, it is the feedback which is the distinguishing factor between the open loop systems and the closed loop systems and is absent in the open loop and is present in the closed loop systems. We will discuss the types of feedback in the upcoming sections of this course. We will also have the transfer function of a control system. But before that, in the very next lecture, we will take a review of Laplace transform.
So this is all about the open loop control system as well as the closed loop control system. And after that, you have a difference between the open loop control system and the closed loop control system. So up till stage that we are covered about your control system, introductory part, open loop control system as well as the control loop closed system. So you people get an idea that how you can distinguish between these open loop control system as the closed loop control system. Now up till stage, anybody having any doubt, he or she can ask me. Is that clear to all the students to be present there? Shall I continue next? Yeah, students, I'm waiting for your response.
Yes, sir.
Okay, fine.
And nowadays, analyzed on computers by the use of softwares. In that case, block diagram representation plays an important role because it can help to build a mathematical model of a control system. Moving on to point number 3, block diagram representation is used to calculate the overall transfer function of the system. As we all know that to find out the output with respect to any given input, we need the transfer function of the system. And block diagram representation helps to find out the overall transfer function of the system. So now we are done with the discussion of introductory points of block diagrams. We will now discuss the elements of a block diagram. We will start with the basic block diagram representation of a control system that we have already discussed in chapter 1. And we all know this representation consists of a block having two arrows. The arrow or the signal which goes into the block represents the input. The signal which goes out of the block represents the output, and the block itself represents the transfer function of the system. But this is the basic block diagram representation of control system. Practically, control systems
Please watch
are more
this video
complex in
carefully
nature.
so
They
that in the
consist of
Monday lecture we
multiple
will
subsystems.
continue from this part
Interconnection
about
of
the
many
block diagram.
blocks are there, which are connected with branches and arrows. So to analyze those complex representations, we need to discuss some more elements of block diagrams like summing point and takeoff point. So now we will move on to the discussion of summing point and takeoff point.
This summing point, takeoff point,
We
I
will
had
first
already
see
discussed
a
with you in
definition
my
of a
last
summing
lecture.
point. A summing point or a summing junction in a block diagram represents the dynamic summation of two or more signals. So wherever we want to add two or more signals in a block diagram, we will use a summing point. This is the symbol of a summing point, which is used to add two signals. If this signal is x1 of s and this signal is x2 of s, then the resultant signal will be x1 of s plus x2 of s. On the other hand, if this is the summing point we are using and this signal is x1s and this signal is x2s, then the resultant signal will be x1s minus of x2 of s. The polarity plays a very important role here. If the polarity is positive, then the signal will be positive. If the polarity is negative, then the signal will also be negative. In this case, the polarity of both the signals is positive and hence the signals are added with a positive sign. In this case, the polarity of one of the signals is negative and hence it is added with a negative sign. Since we are using the summing point or the summing junction in order to add two or more signals in a block diagram, we can also call this point as adder point. So now we are done with the discussion on summing point. We will now discuss the takeoff point. Takeoff point is also called as pickoff point or branch point. So the takeoff point in a block diagram represents a point where the signal branches out and goes concurrently to the other blocks or summing points. Or we can say that the takeoff point in a block diagram is a point where the signal distributes to several other branches. Let us understand this with the help of this diagram. This is a branch of a block diagram, and we can see that from this point, the signal distributes into this branch. So this point is called as the takeoff point in this block diagram. Similarly, in this block diagram, this is the takeoff point, as this point distributes this signal into these three branches. If this signal is R of S, then we can distribute this signal with the help of this takeoff point among these three branches. So this is the basic use of a takeoff point in a block diagram. It distributes the signal from one branch into several other branches. In this way, we are done with the discussion on summing point and takeoff point. We will now move on to reduction of multiple subsystems. As we have already discussed, the practical control systems are complex in nature. They consist of multiple subsystems. And in order to find out the overall transfer function, we need to reduce those multiple subsystems into a single block. We will discuss this under the topic reduction of multiple subsystems. So starting with the first point, in order to calculate the output with respect to any given input, we need the overall transfer function of the system. We all know this. The transfer function is an important parameter in order to find out the output with respect to any given input. Moving on to the next point, when the system is complex, that is, it is having multiple subsystems, then we need to reduce the complex block diagram representation into a single block. And then only we will be able to determine the overall transfer function of the system. So now we can have the idea that the primary target is to find out the overall transfer function of the system. Let us take an example of a practical control system. This is a practical control system.
This type of numerical we have to solve in our class.
It consists of interconnection of different blocks connected with
next Monday. I will
branches
discuss with you
arrows.
all how
And
you can
if we
reduce
want to
these
calculate
diagrams.
the overall transfer function of this multiple subsystem, we need to convert this overall system into a single block, where this block represents the overall transfer function. And the procedure by which we can reduce this complex block diagram representation into a single block diagram is called as block diagram algebra. And the block diagram algebra is based on certain reduction rules, which are called as block diagram reduction rules. We are going to discuss the block diagram reduction rules in the next lecture.
So I think you can just got an idea about this block diagram reduction, how you can apply this block diagram reduction. And in my next lecture, what we have to do, we are discussing about this block diagram reduction, how it can be practically implemented, and आपको next टाइप में आप लोगों को इसके न्यूमेरिकल सॉल्व करने हैं, तो हम लोग उसमें देखेंगे कि किस तरीके से हम इसके न्यूमेरिकल्स को सॉल्व कर सकते हैं. So I think you people got an idea about this control system, the introductory part, open loop control system, closed loop control system, difference between open and closed loop control system, and after that you have a unit that we have started from Monday onward, that is called as a block diagram reduction technique. So is it clear to all the students to be present there? Is it okay?
Yes, sir.
Okay, fine. So this is all about for today's lecture. So in Monday onward, we will start practicing the numericals on this block diagram reduction, how you can sort out this type of block diagram reduction techniques. Okay, ji. So thank you so much for today's lecture.